Right, good afternoon everyone. So today we are going to learn a new chapter, linear law. Basically, we are learning how to understand the linear form and how to draw the line of best fit. So let me show you some equations. The first one is y equals to 2x squared minus 1. The second one is y equals to negative 2 over x plus 1. The third one is y equals to 2 over x minus x. So the first one, can you imagine quadratic? The graph is a smiley face. The graph look like this. So the second graph here is the reciprocal graph. So the graph look like this. And you can see this reciprocal graph do not have any y-intercept. The whole graph move up by 1 unit. This dotted line that cannot be touched by your graph, we name it as asymptote. Now, the third one, the graph looks a little bit similar to reciprocal graph, but slightly different a bit. These three equations, we name it as non-linear equations. The graph is not a straight line. What if I want to draw it as a straight line like this? Same to y equals to negative 2 over x plus 1, we also can draw it as a straight line like this, moving down. The condition here is we need to reduce the non-linear equation becomes the linear form. Y equals mx plus c. Look at these two. Big Y is small y here. The gradient is 2. Y-intercept for this graph is negative 1. Our y have to label as small y. Our x have to label as x squared in order to make the graph become straight line, where the gradient is 2 and the y-intercept is negative 1. It is still not linear equations, but we can form it into linear form as long as it fulfills the condition y equals to mx plus c. Okay, let us look at the second one. Y equals to negative 2 over x plus 1. We can actually write in this form, right? Y is equals to negative 2 multiply with 1 over x plus 1, where your big Y is small y, gradient is m. My big X is 1 over x, and my y-intercept is positive 1. So with this, I know that my big Y I still label as small y, but my axis I have to label as 1 over x. You will get a straight line which is moving down. Why moving down? Because the gradient is negative 2 and the y-intercept is 1. Okay, now the third one complicated a bit. Why? Because you got the over x and you got another x here. We cannot directly read it as a linear form. We don't want both terms got x. Any idea how to eliminate one of the x from one of the terms here?
Times x.
Everything with times x. Xy is equals to 2 minus x squared. This xy as big Y. This x squared as big X. Right? And this negative is actually negative 1 here as gradient. And this positive 2 as the y-intercept. Can you see the y equals mx plus c here? That will give you your graph which is moving down. Big Y is xy, and with the big X is x squared. And the gradient is negative 1, and the y-intercept is 2. Okay, what if I do not want to eliminate the over x here? I want to eliminate the minus x at the back. What should I do?
Move to the other side.
Y plus x equals to 2 over x. So is this the linear form? Y plus x.
No.
Oh, not linear form, because it doesn't look like linear form. X equals to 2
Yes.
over x. Imagine y plus x equals to 2 over x. I can write it as 2 bracket 1 over x plus 0, where our big Y is y plus x. Our big X is 1 over x. Our gradient is 2. Our y-intercept is 0. So we can actually draw it as a straight line already, where the big Y is y plus x. We have to label y plus x here. And at the x-axis there, we have to label it as 1 over x. And the gradient is 2, right? So which means the graph is moving up and the y-intercept is 0. So the straight line will look like this. Yes, correct. Your suggestion is correct. We can also get our linear form in this way. Is there any other way to eliminate the x at the back? We can both side.
Divide x.
Yes, we can both side divided by x. Then we will get y over x equals to 2 over x squared. 2 over x squared, we can break it, becomes 2 multiplied with 1 over x squared. And minus x, of course, it will become minus 1. The graph is not moving down anymore. The graph will be moving up and pass through negative 1. This graph is y over x against 1 over x squared. Gradient is 2, y-intercept is negative 1. So basically, we can always change a non-linear equation becomes linear form as long as you can get the form of y equals to mx plus c. What about if the question asked in this way? You are given y equals to 2x squared minus 1, and then the question give you the graph going down. And then the question tell you also the gradient is negative 1, y-intercept is 2. Now the question asks you, what is a big Y and what is a big X? What is the linear form in this case? If you directly read the linear form from here, y equals to 2x squared minus 1, by right the gradient is 2 and the y-intercept is negative 1. It doesn't fulfill the condition given here, right? So in order to make the negative 1 becomes gradient and the 2 becomes the y-intercept, then you have to find a way to eliminate the x squared here. So to do that, we divided by x squared. That will give us our graph y over x squared against 1 over x squared. Y equals to negative 2 over x plus 1. Okay, this time I want my straight line moving up. With the condition, gradient is positive 1 and y-intercept is negative 2. So can you please tell me what is the big Y here and what is the big X here? If you directly read, the y-intercept is 1, but it doesn't fulfill the condition already. So we have to do something to kasih hilang the over x here.
Times with x.
Times with x. Okay, we times with x. So xy equals to negative 2 plus x. So can you see the linear form now? Big Y, this is our big X. Our gradient is 1, you can see from the equation, and our y-intercept is negative 2. So if we fulfill the condition, gradient is 1 and the y-intercept is negative 2, right? For this graph is xy against x. Okay, let us look at one more example. Y equals to 2 to the power of negative 2x plus 1. So this graph, we have to draw in this way. I want to make it becomes the straight line, which is moving down and pass through the y-intercept of 1. So the gradient is negative 2 and the y-intercept is 1. So now you look back to the original non-linear equation, the x is here as the power. What can we do so that the x go down and then the gradient becomes negative 2 and the y-intercept becomes 1?
Log 2y.
Yes, we will add log both sides so that we can move down the negative 2x plus 1. But what base we should use here?
2.
Yes, for this question, we have to use base 2. Log 2y equals to, okay, now we can bring down the negative 2x plus 1. And after you bring down, don't forget to put bracket because this whole thing will multiply with the log 2 2. So log 2 will give us 1. That will give us our linear form log 2y equals to negative 2x plus 1. So what if I use base 10 here? 10? Log 10 is not 1 already. Log 10 is 0.3010. Once you open the bracket, this 0.3010 will have to multiply with the negative 2 and you have to multiply with the positive 1. So after you open the bracket, do you think you still can get the gradient of negative 2 and positive 1? Cannot, right? So that's why for this question, we cannot use base 10. With that, we know that this graph is log 2y against small x.